Hey guys, so today we're going to discuss one of the most fundamental types of problems that you're going to see in stoichiometry, and that is the limiting reactant type problem. Now when we talk about limiting reactant problems, the name suggests exactly what the problem is. We're dealing with a problem where there is one reactant which limits how much of the reaction can occur. So what we're going to do today is we're going to first talk about the limiting reactant problems. I'm going to give you some tips to identifying these types of problems. We're going to work through a couple of analogy and practice problems, and then we're going to go ahead and let you guys try one on your own. Now the first thing that you need to be able to do to identify limiting reactant problems and solve them is be proficient with both dimensional analysis and basic stoichiometry of converting from grams to moles, moles to grams, etc. So make sure before you continue in this video that you have a chance to go back and review those videos if you need to refresh your memory. So let's start with the definition of a limiting reactant. Now, a limiting reactant in a chemical reaction is not necessarily the reactant that is the least common. In other words, if you have 100 grams of something and 50 grams of something else, it does not mean that the 50-gram substance is the limiting reactant. We have to use stoichiometry to get from one to the other, because the definition of a limiting reactant is it's the reactant which limits the extent to which the reaction can occur. Another way of saying this is it's the one that runs out first. Now up until this point, any problem that you've looked at has been stated something like this, where we combine hydrogen with excess oxygen to create hydrogen peroxide. Now the excess is already telling you that the hydrogen is going to be the limiting reactant because oxygen is excess. We have enough of it. In fact, we have more than enough of it. So in other words, with limiting reactant problems, we go one step further in that we now have to identify first what is our limiting reactant, and then we have to utilize that information to solve for how much product can form. So let's look at an analogy to try to see what a limiting reactant problem really is. I like to use food as my analogy because I like food. So what we're going to do is we're going to make some cheeseburgers. In order to make a cheeseburger, I need to combine 2 hamburger buns, right? So 2 halves of the bun. I need to combine 1 slice of cheese and 1 hamburger patty. So the way this works is we know that for every 2 buns, 1 patty, and 1 piece of cheese, we create 1 cheeseburger. So what we can do is actually write this in almost a chemical formula type way, where the reactants or the ingredients are on the left, and the product, the cheeseburger, is on the right. Now let's say that we have 5 buns and 2 patties and 3 pieces of cheese or 3 slices of cheese. Which of them is going to limit the number of burgers I can make? Well, if you look at this, with 5 buns, I could make 2.5 burgers. With 2 patties, I could make 2 burgers. And with 3 slices of cheese, I can make 3 burgers. In other words, the patties are going to run out first. I'm going to be able to make fewer burgers with my patties than I would with my buns or with the slices of cheese. This means that the hamburger patties themselves are the limiting reactant in this list. We're going to do it again with a similar analogy, and I want you guys to solve it. So now we have 18 buns. We have 10 slices of cheese, and we have 12 hamburger patties, and I want to find what is the limiting reactant. I want you guys to try this one. So pause the video, take a second, see if you can predict how many hamburgers can be created or how many cheeseburgers can be created from each number of these ingredients. Then identify the limiting reactant based off of the one that produces the least number of cheeseburgers. So take a second, pause the video. When you get an answer, get stuck, come back and we'll look at it together. Okay, so now you've had a second to solve it. With 18 buns, we can make 9 hamburgers. With 10 slices of cheese, we can make 10 cheeseburgers. And with 12 patties, we could make 12 cheeseburgers. This means that with the 18 buns, we can make the fewest. This means that the number of buns, or the buns themselves, are our limiting reactant. No matter how many patties or how many slices of cheese, the amount of hamburgers or cheeseburgers that we can make is completely limited by the number of buns we have. So if we were to make this ingredient list, and if we were to actually complete this reaction, we'd only make 9 cheeseburgers in the end. we'd have remaining cheese slices and remaining hamburger patties. So it's great that we can now identify the limiting reactant in an ingredient list or a recipe for cheeseburgers, but now let's do it in a recipe for chemicals, chemical equations. The first thing you need to be aware of is that this is going to be based in stoichiometry. We need to take each reactant and we need to identify how much product it can make. In order to do this, we first take generally what's given, which is the grams of our reactant. We convert into moles of that reactant and then into moles of the product that is going to form. Now, if there are multiple products formed, it actually doesn't matter which product we use. We could use any of the products because of the fact that if it limits the production of one product, it limits the production of every product. Now, in the case of a chemical equation, what we're going to do is we're going to have to predict how much of a single product each reactant can make. Now, the reason we're going to use a single product is to compare apples to apples. If I have products C and D, it doesn't do me any good to know that reactant A produces X amount of product C and reactant B produces X amount of product D. That doesn't allow me to compare the two. So I'm always going to have to use the same product in both cases. The way we do this is we use stoichiometry, just like we have in the past, where we take the amount of reactant A, which is given, and predict how much of product C it can produce. We do this through stoichiometry by converting first to moles of A and then moles of C. We then take reactant B and do the same thing, where we convert first to moles of B and then into moles of C. The way we do this is to figure out how much of C can be produced by both reactants A and B. Just like with the hamburgers, it's whichever ingredient or reactant produces the least amount of product that we would look at and consider our limiting reactant. Now, you're definitely going to want to be aware of a trick to identifying when you're even looking at a limiting reactant problem. Now, in chemistry, I already told you that excess kind of gives away the fact that the other would be a limiting reactant, but if you're ever given the amounts of two different reactants, in other words, I have reactant A, I have reactant B, and I'm given the gram amounts of each, I can guarantee you it will be a limiting reactant problem. And the reason for that is because the odds of exactly the same number of molecules being in each that are perfectly in tune with the mole ratio is next to 0. So if you're ever in a problem given the amounts of two different reactants, you can bet dollars to donuts it's going to be a limiting reactant problem. Okay, so let's take a look at this kind of problem. Now, in this problem, we're looking at the synthesis of sodium chloride from sodium solid and chlorine gas. Now, first thing you need to do is identify if it's a limiting reactant problem in the first place. In this case, what we need to do is look to see what is given to you. We're given the fact that we have 18 grams of sodium and 23 grams of chlorine gas. Remember, if you're given the amounts of two different reactants, you can bet your bottom dollar it's going to be a limiting reactant problem. So because we're given both the amount of sodium and the amount of chlorine gas in grams, we can guarantee almost that it's going to be a limiting reactant problem. Now, what we're now going to need to do is solve for the amount of product that each can form. In the next video, we're actually going to do these practice problems. So what I need you to do first is be able to identify the problems, and then in the next video, I'm going to describe to you how we solve for them. All right, guys, so that wraps up today's video. Let's do a quick recap. We started by defining what a limiting reactant is. Remember, a limiting reactant is going to be the reactant which limits the amount of product that can form in a chemical reaction. We then used the analogy of making cheeseburgers to figure out what is a limiting reactant and how to find it. We then looked at how to actually identify limiting reactant problems in the context of chemistry. And remember, a limiting reactant problem is almost always going to be a problem where you're given the amounts of two different reactants. We can almost guarantee that will be a limiting reactant type problem. After that, we went through how you solve a limiting reactant type problem, where you use stoichiometry to figure out how much of product could actually be formed from each reactant, and then discussed how you identify the limiting reactant based on whichever reactant produces the least amount of product. In the next video, we're going to actually solve through several limiting reactant type problems. I'd like to thank Kevin Lyons for writing, filming and editing this video. I'd like to thank you guys for watching it, and I'll see you in the next one.